Going on, guys? Good morning. Today we're going to continue with our LeetCode problems, and we're going to do another easy one. We'll probably do these for, probably the rest of the week, and then we'll get onto more medium and hard ones. So this is a pretty fun problem. It's actually quite simple, but it could look confusing, and it's actually sort of like a canonical problem. There's this really funny tweet by the homebrew guy who says that 90% of the engineers at Google use homebrew, but since he can't invert the binary tree, he can't get a job there. It's actually pretty hilarious. Anyway, I don't know if that's true. That'd be funny if it was. But anyway, this problem sort of lends itself to a recursive solution, and it's actually only maybe 4 or 5 lines, I think. But I figured, what if somebody's like, hey, do this iteratively, okay? Don't use a recursive solution. So I think we'll try that. So say I've run it a few times, and I don't know. I think it's just funner to do it this way, so we'll give that a shot. So here's what they want you to do. So you have a tree. You got 4, 2, 7, 1, 3, 6, 9. They basically want you to take the root node and swap the children of it, 2 and 7, and then do the same for the children of those children nodes. So basically you'll end up with 4, 7 is now on the left, 2 is now on the right, and 6 and 9 have been swapped, as well as 3 and 1. So I think a good way to do this is to use a queue where we basically add a node to the queue, and then we check if it has children, we pop it off, we check if it has children, and we swap the children, and then we add those in the reverse order, and we sort of continue doing that. So the way that would look in Python is basically you'd have a queue, and I'm going to use a deck actually because decks actually allow for you can do queues in sort of constant time. You can remove from the left and the right in constant time, different than an array, probably because these decks are implemented with some sort of doubly linked list or something. But anyway, it'll run a little faster. So we'll say my queue is going to be equals to collections.deck, and we're going to add the root right off the bat, right? Then what we can do is, while there's still something in the queue, we can go ahead and remove that element and save it into a variable. So I'm just going to call this cur, which is the current element that we just popped off. So we'll bring that out from the queue. So currently our queue has a 4. We just popped it out. Then what we can do here is actually swap the children. Now there's something that we should do is check for null nodes. So if it's actually a null node, we'll just want to move to the next iteration of the loop, right? So here what you can do is then now we're going to swap the children of the node we just popped off, which was 4. That would be 2 and 7. So we'll swap those. We'll say we're going to need a placeholder variable to swap them. And we'll say left equals, and then right equals temp. Okay, so this is how you'd be swapping things. Create a placeholder variable to hold the old value of our left node, and we then basically assign the left to the right and the right to what the left used to be, which is now temp. Okay. Then after that, we can then just add these to the queue after they've been swapped, right? And then the process will begin all over again. Current.right. Okay. And believe it or not, that's actually it. You can run this in this. Oh, hold on. This actually will not work because we're going to want to return root. It's going to want the inverted thing. So let's just make sure this works really quick. Okay, so it seems that worked. Now, what basically is happening here is we're taking, close this, 4, we're removing 4, so now 4 is down here, and then we're swapping the 2 children, 2 and 7, and then we're going to have 7 and 2. And then the same thing happens over and over again, right? Now, and let's just submit this, make sure this works. Cool. I really don't like this thing with Leak. I don't know what's going on with their submissions, their runtime calculator. I guess maybe because it's Python, it's not great. Maybe with something like C++, it'd be more accurate. But anyway, that varies quite a bit. But this does work. Now, something we can do here in Python, which is really cool, is you can actually do cur.left, cur.right is equals to cur.right, cur.left, and this should still work. You don't need like a swapping variable. like in JavaScript or something. So let's see. So that still works. 10%, 5%. Wow, we're just getting worse and worse. Okay. Anyway, that was inverting a binary tree. Pretty simple problem. Go ahead and give that a shot. Try the recursive solution because it might help you sort of understand what's going on better. I might just post that in the description just so that you guys can see that as well. But anyway, simple problem, a good start for the day, and cool. Thank you guys. Catch you in the next one.